So this is the part 5 of the General Education Mathematics Let Review, and we are going to talk about the solution for the numbers 41 to 50. Problem number 41. In how many ways can a president, a secretary, and an auditor be selected from a group of 7? So let's find out the answer.
The answer for this problem is 210. So how to get 210? In this kind of problem, just like selecting people from a group of 7 or any number, it's either we use combination or permutation. But if it involves position, just like president, secretary, or auditor, then you must use permutation. But in case if you just have to use three or choose three people without any position, then you must use combination. So let us use permutation. So here's the formula. N factorial over n minus r factorial, where n is the number of people and then r is the number of positions. So there are 7 people and then there are 3 positions, so r is 3. And then we are going to subtract 7 minus 3, that's 4. And then we expand so that we can cancel and reduce it to make it easier for us to compute. So we can cancel 4, 3, 2, and 1. So you might wonder why the 7 factorial and 4 factorial becomes like that. That's how you define the factorial. So if it's 7, it becomes 7 times 6 times 5 up to times 1. If it's 4, then it's 4 times 3 times 2 times 1. So if it's 100 factorial, it's going to be 100 times 99 times 98. Keep on going down up to times 1. So what's left is 7 times 6 times 5. And the product is 210. That means there are 210 ways to choose who is the president, secretary, and also the auditor from a group of 7. Number 42. In a certain school, 40% of the students have black hair, 25% have black eyes, and 15% have both black hair and black eyes. A student is selected at random from the school. If the student has black eyes, what is the probability that the student does not have black hair? So let us solve this problem. The answer for this problem is 2/5. So how do we get this 2/5? So let us illustrate first this problem using a Venn diagram. So let's have this rectangle which represents 100% of students, meaning all the students. And then we are going to make a circle representing those who got black hair and a circle for those representing those who got black eyes. And then it's given that there are 15% who got black hair and black eyes, so we'll put the 15% in the middle. And then it's also given that there are 40% who got black hair. That includes already the 15%. So what's lacking is 25%. And then those who got black eyes, it's 25%. So what's lacking is 10% to make it all 25%. And then outside this circle will be those students who doesn't have black hair but and also doesn't have black eyes. And then to solve for the probability, we are going to include only those students who get black eyes because it's given that if the student has black eyes, so it doesn't involve all students. This is what you call a conditional probability because there's a given condition that you are choosing from from students who get black eyes. So the event on top, what we are looking for, are those students who got black eyes but not black hair. And the total will be the students for black eyes. So since we have figured out that it's 10% who doesn't have black eyes and not black hair, and it's given that the total student who got black eyes is 25%. So it's over 25. So 10 over 25. And then we reduce it. We divide by 5 because both numerator and denominator are divisible by 5. So as long as it can be reduced, we have to reduce. So 10 divided by 5 is 2, and 25 divided by 5 is 5. That's why the answer is 2/5. So that means the chance of choosing a student that doesn't have black hair out of those students who got black eyes is 2/5. Number 43. 5 multiple choice questions with 4 choices in each items is to be answered by the students in mathematics. In how many ways can a student answer the 5 questions? So let's find out the answer. The answer for this problem is 1024. So how do we get this answer? So first is we are going to illustrate this problem to make it easier for us to analyze and solve the problem. So we're going to construct 5 blocks representing the 5 items. And what we're going to put these blocks are the number of ways to choose from each item. So this is for number 1, 2, 3, 4, and 5. So remember that it's given that there are 4 choices in each item. So we don't know what are the choices, but it's assumed it's A, B, C, or D. And usually those are the choices in a multiple choice items. But I'm not saying it's always. So there are 4 options for each item. So the same as the number 2, 3, 4, and 5. So what we're going to do is to multiply all these choices. So equals 4 times 4 times 4 times 4. It will be 4 to the power of 5, which is equal to 1024. So that means there are 1024 ways. Number 44. Jonathan has less than 100 blocks. When he placed them into 4 equal rows, he had 2 blocks left. However, when he placed them into 9 equal rows, he had none left. How many blocks did Jonathan have? So let's find out the answer. So the answer is 54. So how do you get 54? So first is we're going to illustrate first whatever are the givens. So it's given that it is less than 100 blocks. And then it's also given that if we place them into 4 equal rows, then there will be 2 blocks left. And also if we place them into 9 equal rows, then there's none left. So these 2 givens are actually telling us that if we divide whatever is the total number of blocks, there will be a remainder too. And if we divide it by 9, so there's no remainder. So again, the number that we are looking for is divisible by 9. And if you divide that number by 4, there will be a remainder too. So those facts are the important things to think so that we can solve this problem. Now let's look at our choices. All these 4 choices are divisible by 9. So that means the second condition is already satisfied. And the first condition is it must be, when you divide it by 4, there must be a remainder too. So the second condition is satisfied. What we are going to look for is the first condition, that if you divide it by 4, the remainder is 2. So let's try the first one, the 45. 45 divided by 4 is 11, remainder 1, because 11 times 4 is 44, and there's extra 1. Next is 54 divided by 4, it's 13, remainder 2. So this is actually the one that satisfies the first condition. It's when you divide it by 4, there's remainder 2. Now let's check the C and D. So 63 divided by 4 is 15, remainder 3. and 72 divided by 4 is exactly 18. There's no remainder. That's why the answer is 54. Number 45. Four small squares are put together to form a bigger square. If the perimeter of the big square is 112 centimeters, what is the area of each small square? So let's find out the answer. The answer for this problem is 196 square centimeters. So how to get this answer? So let us illustrate first the problem. Four small squares are put together to form a bigger square. So it's like this. If the perimeter of the big square is 112 centimeters, so we're going to look for the area for each small square. So it's given that the perimeter is 112 centimeters. So what we need to do is to find the area of this big square, and then we divide by 4. But before that, we need to know first the length of the side of each side of this big square. So since each side is equal for a square, then we are going to divide by 4 its perimeter. So 112 divided by 4 is 28 centimeters. That means all these sides, the length, width, and all these 4 are all 28 centimeters. Now let's get the area of this square. So it's side squared, 28 squared. So the area for this big square is 784 square centimeters. And then since there are 4 small squares, so we're going to divide this by 4, which is equal to 196 square centimeters. So each small squares have this area. Number 46. If A star B equals A plus B plus AB and X star 2 equals 5, what is the value of X? So let's find the answer. The answer for this problem is 1. So how did we get 1? So here's the given. It's given that this binary operation A star B equals A plus B plus AB. So the binary operation might be new for you, but it is an operation where the rule depends on the given. So here the rule for the star is it must be A plus B plus AB. So there must be a given rule for the binary operation. Without that, we will not know how it functions. So we are going to look for the X star 2 based on the given rule for the binary operation on top. So here it's A plus B plus AB. So the A here is X plus the B it's 2 plus the AB or the X times 2. So let's simplify. It's X plus 2X and combining like terms X and 2X. So the X star 2 will be 3X plus 2. But it is given that X star 2 is equal to 5. So we're going to substitute the X star 2. So it will be 3X plus 2 equals 5. Then let's solve now for X. So let's transpose the 2 to the other side and it will change sign to negative. Then 5 minus 2 is 3. And then we divide both sides by 3 so that the X will be isolated. And then X is equal to, so when we cancel 3 and 3, it doesn't mean it's 0, but it's 1 because any number divided by itself is 1. Number 47. A pack of 50 peso bill is numbered from RV628 to RV663. What is the total value of the pack of bills in pesos? So let us solve this. The answer for this problem is 1,800. So how do you get this answer? So first is we are going to use this the codes or the number used for the pack. So what we need to do here is to know the number of bills, the number of 50 peso bills. And after that, we're going to times it with 50 so that we will know the value. So to know how many bills, we will use this information. So RV6 is just repeating, so we don't need that. But we need the 28 and 63 to know how many bills are in the pack. So to know the number of bills, we subtract 63 by 27. So you might wonder why 27 instead of 28. So just for example, we want to know how many numbers are there from 6 to 8. So obviously it's 3. It's 6, 7, and 8. But of course, if we subtract 8 minus 6, that's only 2. So instead of 8 minus 6, it's 8 minus 5. So to know the numbers 6 to 8, since we know already it's 3, we must subtract 8 minus 5, not 8 minus 6. Why? Because we include counting the 6. The same here, we include counting the 28 up to 63. That's why we don't subtract 63 minus 28, because 28 is part of counting. So it's 63 minus 27, or the number before that. Okay, so it will be 36. That means there are 36 50 peso bills. Then we are going to multiply 50 and 36 to know the value. It's 1,800 pesos. Number 48. Perform the indicated operation. 70 divided by 7 times 5 plus 64 divided by 4 times 2. So let us find the answer. The answer for this problem is 82. So how do you get 82? So let's copy first the given, and then we will follow MDOS: multiplication, division, addition, subtraction. So first is we are going to divide 70 and 7. So you might wonder why divide first, and while in MDOS it's multiplication and then division. So actually multiplication and division in the MDOS is actually not in order. It depends on what is coming from the left. It's multiplication or division, as well as addition or subtraction. It depends on what is from the left side. So if division is at the left of multiplication, so we're going to do it first. So again, we are solving from left to right. So let's divide. 70 divided by 7 is 10, and then we copy the rest. Next is we multiply 10 times 5 instead of 64 divided by 4, because it is at the left side. So 10 times 5 is 50. And then we have 64 divided by 4 and 4 times 2. So instead we do 64 divided by 4 because it's at the left side. So 64 divided by 4 is 16. And then we only have two operations left, the plus and times. So no confusion with that, because you always do multiplication or division first before addition or subtraction. So 16 times 2 is 32. And then 50 plus 32 is 82. And that is the answer. Anna has 3/3 cake. Her brother ate 2/3 of it. What fractional part of the cake was left? So let us solve this problem. So it's given that there's a 3/3 of a cake, which is actually a whole cake. And then Anna's brother ate 2/3 of it, so we will minus 2/3, because what we are looking for is what was left. So 3/3 minus 2/3 is 1/3, and I think that's too easy for this reviewer. So, and observe that the answer is not in the choices. So the thing that makes it too easy in the choice, the answer is not in the choices, is this 3/3, because I believe that this must be 3/4 instead of 3/3, because if we want to write it as a whole cake, so we will just write Anna has a cake. So we will correct this, and I just copied this exactly the questions coming from our reviewer. So we will correct this so that we can have the answer from the choices. So we will replace this 3/3 into 3/4 and we will solve. So here's the corrected problem. Anna has 3/4 of a cake. Her brother ate 2/3 of it. What fractional part of the cake was left? So let us solve this. So the answer for this problem is 1/4. So how do you get 1/4? So it is given that Anna's brother ate 2/3 of the 3/4 cake. So the cake is not whole, by the way, it's only 3/4. So 2/3 of this 3/4 cake is eaten. And then what's left is 1/3. Not 1/3 of the whole cake, but it's 1/3 of the 3/4 cake. Because again, the given is not the whole cake, but it's only 3/4 cake. So we are going to look for this 1/3 of the 3/4 cake, because that's what we are looking for. So we multiply this, but to make it easier to multiply, we reduce whatever we can reduce. So 3 can be divided by 3, so we cancel. And then we multiply. So 1 and 4. So 1/4. Number 50. Which of the following is the smallest prime number? So the answer for this question is 2. So why is it 2? Let us define first what are prime numbers. Prime numbers are whole numbers that can only be divided by 1 and the number itself. So 0, it can be divided by 1, but it cannot be divided by itself. Also, for 1 can be divided by 1, and it can be divided by itself, but itself is also 1. So that makes it not a prime number, because it is divided by 1 and by itself, which is also 1. It must be a different number. Here we have 2, which is divisible by 1, and it's divisible by itself, which is 2, which is different from 1. And it is a prime number. Also for 3 is divisible by 1, and it's divisible by itself, which is 3. And again, it's different from 1. So again, prime numbers must be divisible by 1 and itself only, no other numbers. So 2 is the smallest prime number. So thanks for watching, and I hope you have learned from this part 5 of the Let Review videos. And please check out for the part 6, which is a continuation of this video.